Hello everyone and welcome to a brand new channel, Horizon Across. Let's enjoy learning. So, now that we are done with this wonderful intro, let's get straight to business. So, what is universe? Is it a sphere? A cake? A human? Probably not. Actually, universe is like a balloon. Yes, you heard me right. Because universe is continuously expanding. Just like this balloon. I mean, not just like this balloon, but like this balloon. It is continuously expanding. But there's a huge difference between this balloon that is in my hand and a universe. And that is that this balloon has something known as a physical limit. And if I push this balloon beyond that physical limit, the obvious answer will be, well, this, an explosion. So, the second question will be, is a universe going to explode like this balloon one day? Will a universe collapse on itself just like that? The simple answer to this question is, we just don't know. And that's that. And probably we will never know. Now you know what is the universe. So you will be naturally curious to know how big is the universe. In simple words, it is way bigger than you can possibly imagine. But in complicated terms, well, that's a completely different story. And that's probably why you are here. So let's get straight to business. So before starting, you need to know something known as the observable universe. Basically, the observable universe is the limit to which we can observe or see the universe. Now, the obvious question that you might be asking is, why is there a limit till which we can see our universe? Why can't we just see the whole universe? Is it because of the technology? Well, partially. Yes and no. Because this is where the speed of light comes into play. Now, no offense to the speed of light, it is very fast indeed, and nobody is judging that. But when we compare it to the heavenly distances between different heavenly bodies, then it turns out to be pretty slow. And now compare that with the expanding universe, it becomes very, very slow. So, some light from far off place in the universe would never be able to reach us because of its slow speed. And the universe is also continuously expanding. So, the distance that light has to cover is continuously expanding. Thus, it would never be able to reach to us, creating a physical boundary for us to observe the universe. Sounds interesting, huh? So, the second question that you might be asking now is, how big is the observable universe? So, let us say that this balloon in my hand is a universe filled with millions, trillions, billions of galaxies. So where is our observable universe? The answer is, nobody exactly knows. It can be anywhere. It can be here. But for the purpose of continuing this video, let us say our observable universe is here. And that is this big. I'm not sure you can see this. Yeah. This tip of the matchstick, that is our observable universe compared to the real universe. It is some 3 or 4 million light years, something, I don't really remember. But that is exactly how big, not exactly, but that is how big our observable universe is. This much. In my hand, in this red dot, somewhere is us. This red dot contains millions of galaxies and stars. And this is really mind-blowing to imagine. But this is not where we stop. This is just the tip of the iceberg. Now let us say that this balloon is the observable universe. And when we dig deeper into the observable universe, into the million galaxies, we find something known as a supercluster. Now, what is a supercluster? A supercluster is a huge collection of stars and galaxies and black holes sometimes. So, where are we? Where is our supercluster? Now, our galaxy and our planet is in a supercluster known as Virgo supercluster. So, where is Virgo supercluster inside this observable universe? In reality, it should be somewhere over here in the corner and stuff, but just for the purposes of this video, I'm going to say it's here. So this tip of the matchstick is again a Virgo supercluster. Virgo supercluster has a million or so galaxies inside it, and one of that galaxy is Milky Way, or home, or maybe or close home or something. Let us say that this balloon is Virgo supercluster. So, where is our cluster? Now you will be like, what is cluster? Now, a cluster is just a cluster of galaxies. That's basically it. But it is not as big as the supercluster, and thus it is just known as a cluster. So, where are we? We are in a cluster of galaxies known as local group. It is known as local group because we are present inside that group. So let us now say that this is the Virgo supercluster. So where are we? We are somewhere known as local group. Now what is the local group? It is basically a cluster of galaxies. Inside superclusters, we have multiple clusters of galaxies, and one of that cluster is named as local group because we are present inside this group. So, how big is our local group? It should be this much compared to the Virgo supercluster. And our local group contains around 30 galaxies. Sounds small to you, huh? So right around us somewhere is something known as a Virgo cluster, another cluster of galaxies, which is not much bigger or smaller than our local group, and it contains 300 galaxies. Our local group is just sparsely filled, I can say again. So now let us say that this balloon is the local group, and in the 30 galaxies that are present in this local group, where are we? Now for comfort, let us say that we are present right here, and this should be the size of our galaxy compared to the local group. And comparing to the universe, we are literally invisible. Again. So now let us say that this balloon in my hand is a Milky Way galaxy. The Milky Way galaxy's photo will be somewhere around here. So yeah, this is a Milky Way galaxy. So where is something known as Oort cloud? Now what is an Oort cloud? Oort cloud is a cloud of icy particles surrounding or galaxy, or no, not a galaxy, or solar system. And that should be around this big or even smaller compared to our galaxy. Now let us say that this balloon is the Oort cloud to wrap stuff up. So where is our sun? Our sun compared to the whole Oort cloud should be this much. That's all. That is our sun, and we are somewhere around here revolving around this sun. Now, I'm kind of bored with this balloon, so let us just throw this for some time, and let's say that this soccer ball, which is way more interesting than the flag and balloon, is our sun. So how big will our earth be? Well, guess what? Look at the tip of this pin, thumbtack, whatever you would like to call it. That is our earth compared to the sun. And this is the sun compared to the Oort cloud. And this is the Oort cloud compared to a galaxy. And now, think about the universe. How big would universe actually be? It's very big and possibly way bigger than you can imagine. I would have loved to continue this video with the composition of the universe, but this is enough information for today and I'm also pretty worn out. So I'll meet you in the next episode, which will be out in around the next month, the same day. So if you like this episode, this is my first episode and I'm really anxious right now. So if you really like this episode, then press that like down there and there'll be a subscribe button somewhere around here. So press it, make it grey, and then press the notification bell beside it. And if you really like this video and want other people to know that you like this video, then share this video. If you think that someone would like this video, then share this video, and just please share this video so that we can reach to more people. Thank you for watching.